Good afternoon, everyone. Today we have Dr. Shyama Chowdhury with us. He is a senior manager at IBM India Private Limited. Before that, he was working as a deputy general manager at Samsung Electronics, and he did his PhD from Queen's University, Belfast, that is UK. And before that, he obtained his master's degree from Bengal Engineering and Science University, Shibpur. Now it is IIEST, and he has many publications in the domain of computer vision, machine learning, and artificial intelligence related area. So we are very lucky to have Dr. Chaudhuri. So yes, Dr. Chaudhuri, we can see your screen.
Yeah, and my voice is
So
clear, right?
yeah, so I
Yes. Should I start or we'll wait for a couple of more minutes?
yes. So we can start actually
Yeah,
because there are other speakers as well. So I request you
sure.
to start the session. Thank you very
Thank
much.
you. Thank you, Doctor. Um, so today the discussion topic is real challenges in big data analytics. Myself, Shyama Chowdhury. So I mainly work in the domain of image processing and computer visions, and also then different type of data analytics. And right now, one of my main focus is working on the big data analytics. There are the few reasons I'll be explaining you one by one. So first, let us see that what is our tentative plan for today's discussion. So in these discussions, what we will be discussing is understanding why big data and big data analytics. Then in that discussions, we'll include a little more customer-centric applications. So I'll not be showing you any applications or how to write code or how to deploy that some Docker images or how to solve that one particular customer problem. Rather, we will focus in today's discussions is thinking what customer-centric applications could be using the big data analytics. And main focus in today's discussion is the real challenges. Those challenges, there are a lot of mathematical equations maybe we may find, but actually in real life, so those life is not that easy. That in few parametric equations it will run. So those few real challenges where it will actually we need to focus more and what we need to think. So that from that perspective, I have designed that presentation. Yes, that 1 hour will be very less. I'll try my best to move very fast, and at the end, I'll try to provide enough time for discussions and for question answer kinds of things. And what we will not cover, like I said, that developing solutions, detailed algorithm to solve a specific problem, detailed mathematics for a particular type of model, or hands-on practice that is not included in this discussion. First of all, what is big data? You will find that big data, it was not when we were about to join our colleges, those times we haven't heard about the term big data. We had that time that we did DBase were there. Then it comes the RDMS was popular at that time. And now also RDMS is very much popular. And yes, it has directly no clash with the big data. Rather than in few places that were no SQL, we think of we are giving that precedence. This one that the big data, actually, truly speaking, I heard that term big data not before 12 or 13 years back. So around the 12 years back, I heard the term that big data, and that time we were not sure that what the big data, and we were working on the different data hub. We were that time was thinking to define that different AI problems and solve them with a huge volume of data. So those things we were actually looking for. And for the term big data, we thought that yes, it would be something like the similar what we were doing. And so first academic paper, it was presented in 2000 and published in it is published in 2003 by Depaul. John Meshy is we gave that credit from the SGI Silicon Graphics. So we gave them the credit to use the term big data. In late 90s, Messi gives a series of talks on small groups about the big data tidal wave that is coming, the big data era, and how it will rapidly expanding, and the data volumes is growing very fast. So that concept he has actually given at that time. We missed that those we were not that much aware. But nowadays we cannot say this smartly that sorry we were not very much aware of that. People will say, oh, you don't know the big data. Uh, and we have to say that yes, we know big data little bit. Now, in 1 hour discussions or something, it is not possible to understand each and every aspect. Also, without knowing what is big data, it is difficult nowadays to have discussions and to design our analytics. This this series of discussions, I found that mainly based on that analytics, different analytical model, different learning techniques. So those things are very much relevant to this series of lectures. However, I initially I thought that I'll be presenting something on that like ELO V4 model or something that RCNN. So those things I initially planned, and then I thought, um, how will it be if I just give a little more different topics and present that in terms of analytics, why big data is important. So today our topic is on big data analytics, and so it is I'll not be exploring the big data, rather big data in perspective of analytics, and that what are the real challenges we may face. First of all, that what data is why the volume of the data is important. We know we more or less heard about the gigabyte. It was that hard disk we have. Also, we are the smart guys. Nowadays, we have the hard disks of terabytes, but gigabytes are standard. Was standard even 5-10 years back. And yeah, I'll say our professors will say gigabyte. They actually heard about the hard disk of only a kilobyte or few kilobytes or megabytes, not the gigabytes. Early days. In my college days, also it was that. From the megabyte to gigabyte, it was just raised. Now, after that gigabyte, in today's world, terabyte is also very familiar term for us. Now, petabyte or zettabyte, those things we are not very much familiar. But the days are coming, we have to be very much familiar with all these terms, and we should know that what exactly that means, because we have to touch and feel. So those days are coming. In video, just for an example, how the data accumulates and it actually grows in volume. For video, an uncompressed HD image, RGB video, It is that there is a small calculations, and high definitions means that 1920 into 1080 pixels, 1920 columns and 1080 rows. We say that in the HD representations. And um, for each of that, we required the 3 bytes of information per pixel, because red, green, and blue, and running for 100 years would amount approximately 600 petabyte of data. So this petabyte, so terabyte we know. So for petabyte, one video stream is recording without any further compressions. After 100 years, it would be approximately 600 petabyte. From music perspective, 1 petabyte of average MP3 encoded songs for mobile, roughly 1 megabyte per minute, would require 2000 years to play. So a petabyte from our daily perspective, it is a big data. In 2018, International Data Corporation, they estimated that global data sphere will be around 175 200 zettabyte by 2025. So now we say that from terabyte, petabyte, zettabyte, so it is now growing. In CERN, they work on that petabyte of data. Now, in big data challenges, we have the different type of requirements, different type of customers, and each customers for a particular customers, maybe a public sector customers, we may not need all the we have the different flavors for the big data. For some public customer, some public domain, so it is also not required. So it is a mix up. From if I need to do the archives, here we'll find that most of the data are structured, and also if we have to go a little beyond, there is a lot of also unstructured data. In documents, it is full of mixture of structured and unstructured data. However, in different business applications, it is more or less on the structured data. So here the two different types of data we are discussing. It is one is the structured data, another is the unstructured data. From for big data perspective, it is very important to understand what is structured and what is unstructured. Let me tell you. Earlier, what I have actually given you, that examples of the video and music, both of them are unstructured. It is not properly structured. So for data volume, going from gigabyte, terabyte, and petabyte, so those are mainly unstructured data. So unstructured data has of immense importance in big data analytics. Now, if something is given on the relational table very clearly and with proper design, like I have this many employees in my office. So what is how much salary do I have to pay at the end of the month with different consideration. So for this type of calculations, we have everything, all the rules we can set in a table, in not in a table, in different table or in a database, and we can calculate. However, if I require, like I have one camera installed in front of my office, and if I want to search that, oh, my employees in my office are coming, and are they feeling tired or they are refreshing? So for that type, so for that type of requirement, we don't have anything structured data, like we cannot just search a table and we cannot just find it out that whether uh, people are very enthusiastic or they are already tired by their journey. So those are the unstructured data. So structured and unstructured, there are the two parts of the data, and big data analytics mainly on the working with different unstructured data. So in CERN, the data they collect from different sensors. Those are, most of them are in the unstructured in nature. So if the requirement is very specific, we'll find less of the unstructured. However, if the requirement is not that clear, we'll find it like unstructured. So in big data, there are the three V's are important. Based on these three V's, in big data, we define that how it is going to be, how big. Always that question is that we are telling that it is a big data, and so that the big term is always there. So how big? So it actually depends on three V's. One is that velocity, one is the variety, and another is the volume. On this 3V, if we see the for the archives, that velocity is not that high, but volume is high. For documents, you will find that the velocity and the volume, those are not that big, but different varieties. For business applications, varieties are less, but velocity and volumes are high. For media, um, that volume of data is really very high, and for velocity and variety, yes, as much as this can spin. As that term suggests, these three V's, they actually mainly determine different requirements on the big data and how these different problems in the big data should be handled. Now, if we do that real comparison of that big data analytics in terms of from the traditional big data analytics, then we'll find traditional analytics, they mainly focus on the descriptive analytics or diagnostic. I'll never say that traditional analytics cannot do the predictive analytics. That I'm not saying. It is not my intention. But my intention is to tell what was the most of the problem we have solved, those focused on the descriptive analytics and diagnosis analytics. However, for the big data, descriptive analytics is not that of a highest requirement, and no one will deploy big data analytics in their system for descriptive analytics. Rather, they will always ask for different perspective analytics. They will say finding out different data science parameters out of it, finding the outlier. So those things will come. And over there, that big data is of huge importance. In traditional analytics, data sets were limited and it was already cleaned and that model was simple. However, I say that clean data means, suppose if it is in the name field of my employee of one organization, so name field could be Akash, Abhishek, John, Abhay, uh, in any name we can think of, but you will never find that it will come something like a story, and you have to find it out, the you have to search name out of it. However, in big data, as we are mainly working on that unstructured, so that our data, it is not in that the simple model, and also it is, we may not find it is always cleaned. If it is a traditional analytics, a clean data means if it is my name is there, Shyama Prasad, then Shyama, then one space and then Prasad, it will be there. If it is only the name, and if there is a possibility of having the middle name, then obviously Shyama will go to my first name and Prasad will go to my middle name. That is fine. But in the big data, it may not be that fine. It may not be that precise. You may find that there's some underscore in between Shyama and Prasad, and it is that name. You may find that in the Shyama and Prasad, there are the few inverted commas. Inside that inverted comma, it was written. Because in big data analytics, one of the major challenge that you should, so there are the few points that from this today's discussion you should take away. So one of them, in big data, it is not an intended employee or uh, intended data people is inserting the data. It will never happen. For the big data, most of the things we find from our environment. We find for different media, we find from different reports, we find in the several unstructured way. And we will never get that very clean data out of it. Because even, just one example, most of you, all of you, you are not that undergraduate students, sorry. So most of you, all of you rather, have filled the bank form for opening an account or taking some bank loan, and you will find there were clearly given that boxes where you have to write the name, where the first name will come, where the middle name come, where your surname will come. But in most of the cases, we will find that we are not very much sure of where exactly we'll put. After my middle name, how far it will be on the surname, if it is in the single line. Obviously, in many cases, you will find in that very clear. But in most of the cases, I find those are not that clear. We find that those are very much unstructured, and when we fill it up, we don't know exactly what to do that. So there are the few people who actually translates this to the electronic version. They do it. For us, it was, so for here, that conversion from the unstructured to some structured is doing by some people who is actually physically entering that data. For big data, most of the cases will work. There is no data operator who will be just entering those data. There is no one. We have to read from the video, we have to read from the newspapers, we have to read from the several websites. So it is a real mess over there. So one big challenge is having the clean data, and for that one, or for that, you may need to find it out your own logic, own algorithm, or some mathematical functions. Why I'm saying that mathematical functions, we face this type of problem in one of our work, that we were predicting for one airlines, and we found that amount of that one every flight tickets was coming to us in with different currencies, and even that formats were very different. Sometimes it was with a comma separator, sometimes it was a colon separator, sometimes it was a dot separator, sometimes we can assume that even in the dollar or pound or any of the currencies, after 2 digits, there are no meaningful value. Like suppose I'm spending uh, 200 rupees, then it will be 200.00. But it will, if I spend 200 rupees and 1 paisa, in that case it will be 200.01. But it was not expected that something will come like 200.003. And when we tried to work, we found that there are the different types of data. And most important things, when you have to search your own data in that domain, as it is not structures, we have to use the different regular expressions. And with those regular expressions, you have to take. So one of the very big challenge, obviously, it is. I will not say this is a PhD challenge or solving that some research topic, but you have to take care of those type of things. Otherwise, we may face different types of problems. And for traditional analytics, that support system, it is mainly what happened and why, but here it is that correlations, that more accurate answers that we need in that big data analytics out of those highly unstructured data. So what I was actually discussing, in big data, it is actually dependent on 3 V's: volume, velocity, and the variety. Now, in this graph, so here in that left hand side, you can see this triangle, this big data, and that complexity or the challenges or the volume, whatever you will tell, that that rather it is that the complexity, I'll say, or what is that the actual that big data, how dense it is depending on the 3 V's. Now when we were working in right hand side, if you see that graph, when we were working on the RDMS, mainly on the different ERP system. So over there, it was so that the different types of like purchase details, purchase records, payment records, then attendance records. So blah blah blah. All those things we were working on that ERP system, and those were in that volume. If I say that it was not that high, it was on the lower end. So the total content, it was not that challenging for us, so we can handle on that ERP. Because in the ERP, no one will tell you that okay, from this video find it out some analytics, or no one will tell in ERP system like in the website today, see what is that. Suppose Djokovic, he couldn't win the gold in Olympic. We have seen that. So no one will ask then what is the Djokovic fan base? Is it decreased or increased in ERP system? No one will ask you. In ERP, that main problem will come like, okay, maybe if it is on that some on some tennis related issue, so it will be how many matches he won, how much earning he made, or like that. But no one will ask that other difficult questions. Then it comes at our CRM, and here also it is little bit increased. Here we have to provide the customer feedback and the different offer details. So those things we have to provide. Now, when it actually came to web, we had many things like that. in web we have that one of the very important thing is the dynamic pricing, like that. So all the competitors for online selling portals, they are trying to get the customers. Now, what is that the best offer they can provide? So on when it comes on that the dynamic pricing, so over there, that volume of the data we have to analyze, that complexity, variety, those are increased. In big data, it is on the highest level of nowadays, that in terms of that data volume or that complexities, if you merge together, if you multiply, so you will find um, that in big data it is of the highest volume. Like this one, I can tell you one with one example. Like in we know that formula, like some distance covered in some time. So what was the formula? It was in our class 10, 11, 12. That time we class 11, 10, 11 we did we learned that formula: S equals to ut plus half ft square. So over there it was determined with the area, and in area one dimensions was the velocity and another dimensions was the time, because ut you have to define. U is that the initial velocity, and that suppose we don't have, even if we don't have that acceleration, then after sometimes what is the distance you will be covering, it was that velocity and you have multiplying the time. So we were getting into in some area. Here also for the big data, you will find that the variety and complexity, and we are multiplying with that this volume, that how much. So in big data, this area, multiplying that the volume and that variety and complexity, it is the highest. For the ERP, it was the earlier we were working for so long, it was good. It was of very we can handle it easily. And then in as it actually further progressed, now from CLM, web, and there are the different other things. Now in the big data uh, era, it is that the highest things we have to take care. Um, Here, that one of that in big data, I didn't talk about it intentionally. It is that the social media data. The reason is that in the social media earlier, what was happening, that generator of the data were few limited entities. So, and others were consuming. So if we think of that source and sink model, so sources were limited and sinks were huge. And very early the sources limited, sink was also limited. Then it came that sources were limited and sink is huge. Nowadays, the big data, the importance is also getting prominent when we found that number of sources are so high. We all the time we post something in Twitter, Instagram, Facebook, something like that. We so that different organizations how we actually behave. So all of them are at some point of time are information about myself, and it was the data. Now each of us we are generating that data. Like someone in USA, I even don't know, have generated some video and shared, or maybe he has the same interest as of mine, and I posted something and he replied. Just think of that. Now it was n cross n. Everyone is generating the data and everyone is consuming. And moreover, everyone is generating, everyone consuming. Again, from each of the consumption points, we are generating on that same data. So it is now that full of data, and it is that like that full of that it is filled with data. Here, if we have to come up with that what we were doing traditionally, so we have to work on that big data and we have to understand. So in big data, these are the challenges. Now we have to take care that we have to assume that all of them are the sources. So this is that another point you should remember. Now the number of sources are huge. And I'll tell you one example. One of the uh, railway company I worked with, they are working on the sensory data, and those sensors were installed inside their locomotive engine. And so it was the different vibrations, so a lot of things, different thermal sensors, piezo sensors. So it was some very complex system they had. And they were, so all those sensors, they were generating the data. And every second they were generating not less than 5 instances. Now think of that. Every second it is 5. In 60 seconds, in 1 minute, it is 5 into 60. And in an hour, it is 5 into 3600. That many informations from one sensor. So, so in a day, it is generating a huge volume of data, and it was not one sensor. It was a system of hundreds and thousands of sensors attached. Now all those data, it was from one locomotive. We don't know that how many such locomotives are there, and if there were other systems also. Because in every locomotive there could be the other analytics also that we were not very much sure. We were working on on some focused research that we need some predictive maintenance. Oh, I said that predictive maintenance. So it is on the, so as we have discussed earlier, so it is on the prediction. We are predicting predictive analytics. So here in the big data, that volume of the data handling it, this is really challenging. Nowadays, so you'll see, you'll hear that the term is like cloud. All of you are very much familiar. Now, because of the big data and that huge volume of data, people are again now thinking of not going to the cloud at all and working on the edge solutions. Right now, I am also leading one team. They are working on that particular edge solutions. That means why the data is generated, let us process there, and what is the extract, send that only to the central server or some cloud. So now it is not that trend, that big data. I'm not sure that when the trend will break, that big data will not ask all of the data without any of the further analysis, just sending it to the cloud. The requirement we are having nowadays in industry is that, okay, we have a huge volume of data. It is not always required to move everything to the cloud, process it locally, process it on the edge, and then that your process output that you may send to some centralized location. So already people are thinking in this way. I'm not telling you that cloud sending those data to the cloud will not work, but from the cost effective, from the complexity, so from all this perspective, big data also helps edge processing a lot. Big data also requires that edge processing to come. So here that the volume of the data, there is one small graph. It was a very old, but it was I have taken from world data, but it was intentionally. Just see, in January 2007 to June 2012, what is the data volume, how it actually increased. So if it was the trend that 400 million tweets in 2012, when most of us, we haven't think of tweeting in Twitter, now you can imagine where it is going. The data volume, it is increased from 2009 to 2020 from 0.8 zettabyte to 35 zettabyte. So it is a huge volume. It means we are increasing that for data. So to all of the data, if we cannot process, then it is of no meaning. If we cannot extract out the information out of data, then it is no meaning to us. So the data is equals to information plus redundancy. That is that very basic formula we have in the information technology. Now, from the data, if we don't know how to extract out the information, then there is no information, and then everything is redundant. So if we cannot extract out, if we cannot use that analytics on data, then that data is nothing but junk. So we have to use the analytics, and we have to use on that huge volume of data, and which is actually increasing day by day. That is that most important thing. It is not only that we have a bulk of amount of data, okay, let us go, let us employ 500 people and let us then process and let us just get out of it. No, it is not that we have that something solutions we have, or something that requirement. That requirement is we have that huge volume of the data, and though that data we have to analyze, we have to deploy the analytics on that data, and the results we only need. So from the variety perspective, on the different complexity, now you'll think that you can see here that one small glimpses that earlier we had a very structured data. As I said, this structure in big data analytics doesn't mean any sense, because in social media, suppose I am writing something to, suppose I am tweeting, I'll not be doing like that. Suppose I'm tweeting that on the match India lost against England. Now I'm not putting like that first 5 words for that name of, for that exact information of what I want to say. Then 10 words which test match I want to comment. Then another 10 words for what I want to comment, and then for another 10 words, then for which who is cricketer I want to tell, then another 10 words about what bowling or batting or fielding, something like that, and then exactly what I want to say. So it is not that structured. It was we faced on that. We actually worked on the RDBMS system or the different ERP systems. Here, that complexity is huge. You just think that in social media, that Facebook, that Twitter, Pinterest, so all of them, they have different kind of structures, and they have the different types of methodology to express. In gaming, there are different types of that information it is gathering, different sensory values. We have that purchase, and from the purchase, so Amazon has different type, then that Lowe's has different type, IKEA has different type, our Snapdeal has different type. So this is completely different. In entertainment, Netflix, the way Netflix streams and the way Hulu streams, those two are not the same. we have to take care of each of the things differently. Suppose I have to suppose some task has been given to generate the text out of the conversation automatically, and the way I'll be storing that and way I'll be maintaining for Netflix it will be different, and for suppose for Hulu or something like that, the Sony Live, it would be completely different. For different banking sectors, the way American Express process and the way that Visa process, these two are the completely different. So, however, when we are working on the big data, we will never get enough time to structure all of data individually with a proper manner and then work on that. We have to, like what I was telling, suppose I have to work on that, maybe a Visa and American Express. So I may not have that exact resource with me, that I'll be deploying few of them from a Visa and few of them to American Express and structure them uniquely so that I can process them very easily. Even so, if I can do that, next, if that HSBC comes, for HSBC, I have to do the same process. Rather, in big data, we may not get the chance to work for each of them individually. Rather, we have to come up with some plan which fits for all of them easily. This is that the challenges in the big data. It is not the challenge to convert the unstructured data only to a structured one. Rather, we have to come up with some automation that common automation that will work more or less same for Visa, American Express, and other companies. So that is one of the very difficult challenge we have. Like one thing that I was working on the different type of processing of invoices, and over there we found that all the invoices are of completely different structure. Suppose, for an example, I own one medicine shop, and in medicine shop, all the I'm getting all the invoices from different medical companies. Like I'm getting from Sun, from Abbott, or like that. Now, having that hard copy, I can convert it to a soft one by scanning that. Now, when I have to read that one, if I knew what is the structure, if it is in a single structure, it would be easy. But if I don't know that what is that exact structure, then that document is unstructured to me. And once it is unstructured, from that unstructures, we have to uh, extract the information so that it works for all of the vendors. So that is one of the big challenge in big data analytics. One real challenge we face, that we have to come up with a common methodology what works for all of them in that group. So, yeah. Now that come to that point, to the velocity. In big data, what I was actually telling, data is being generated first and need to be processed first. It was not that scenario that I have already given one chunk of data and I'll be working only on that. But rather, here the challenge is that we have to work on continuously growing data, so that the data is generating every time, and we have to process first and we have to stay updated. Here in big data, people are so that existing system was always working there. Now, why customer is paying me? So this point, we have to now think here, because in big data, it is not, if the customer don't get that benefit out of it, they will not uh, pay me to implement that big data environment. So if they don't pay, I'll not get my bread and butter. So if I have to earn my bread and butter, we have to provide the solution to the customer so that they feel benefited, so that they can see the benefits. So our customers are important. For the customer, if the decision, if that the outcomes of the big data analytics, if we present it late, then it is not valuable to them. So they will miss the opportunities. Like if suppose Amazon and Flipkart, both of them are providing the best deal to the customer. Now, if I see that Amazon uh, came up with some fantastic valuation of one of my product I was looking for than Flipkart, then I'll definitely buy it from Amazon. Now in the Flipkart, they may think it may be the situation there that people working from that for Flipkart was already had that information. Now that the value of the price can be lower, but they cannot process that information. They didn't have that ready in their hand, so they couldn't use that information. Then it is a lost game. So it is always that decisions has to be on time. Otherwise, there is very less value of that analytics outcome. The same in the healthcare monitoring. Suppose that sensors is monitoring that activities and body, and if any abnormality comes, we have to report it immediately. Otherwise, if we go for late reply, then there is of no meaning. Now, here that I'll not go into that more details. It was that mainly I was trying to discuss, and so last couple of minutes I'll be keeping further discussions. What do you think? It is not, I'll not a question answer session, I'll say. It would be the discussion. So if you want to discuss anything, I'll also listen. So yes, please.
So, dear participant, is there any questions with you? You may ask me via unmute yourself, or you can type at the chat. Thank you, Dr. Chaudhary. It's a nice and wonderful talk. And we have our director, Professor
Yeah.
Suman. So, sir, are you available, sir? Professor Lee, maybe some network issue.
Yeah, it was a very good lecture by Dr. Chowdhury.
Thank you, sir.
And, but I was thinking that if you could go slightly in somewhat more detail.
Yes, sir. Next time, if I get chance, I'll definitely go into the more details with some different applications.
Yeah, with different applications. And for example, you have pointed out very important issues in big data, and one of them is that since the nature of the data is all structured, unstructured, all together, so how to take care of such a situation where we have got, suppose, the multimedia data, image, video, text, graph, all together, and then maybe even speech. Then how to take care of such data, which are coming at a fantastic speed, as you very rightly pointed out. The velocity is very high, the variety is immense. So how to
Yes,
take care of the data
yes,
in such situations, and a little bit more on the edge computing.
yeah, yeah, yes, sir.
Basically, the different issues related to edge computing. That means how to find out the overall, granularity of the edge computers.
Yes, sir. Yes, sir.
Whether it should be, what should be the complexity of such edge processors?
Yes,
Because
sir.
in general in edge computing, for example, let's take the case of say telemedicine. Because in
Yes,
telemedicine,
exactly,
today we
exactly.
have got, say, in many villages, there are people who have started a small, shop kind of a thing. I call it shop because
Yes, sir.
they are, doing a little bit of pathological testing. They are doing a little bit of radiological testing.
Yes,
But a simple thing, say, for example, the ECG.
yes,
So we need not send everything from the rural village to the cities, doctors, experts,
yes,
nor should we send everything to cloud. But importantly, maybe that in today's world, the granularity can be very small. That means the ECG machine itself can have a processor which will say that what is the nature of the ECG, whether it is normal or abnormal. If it is abnormal, then what kind of abnormality is there, etc. Whether there is any arrhythmia or not, that means lack of rhythm. So as you rightly pointed out, so we should call that as edge processor then.
yes, sir. Yes,
Something
sir.
like, even can we talk about very low granularity where in the camera itself you have worked a lot. In fact, Dr. Chowdhury is an expert in video data processing, and he has worked very extensively in these areas, video analytics. So anyway, he did not cover much today, possibly thinking that, okay, there are, yes, some students, so it was a wonderful talk. Next time, maybe that if you can, uh, if
Surely,
you
sir.
can
Next time
take
I'll
time,
take more
yeah,
time and
slightly more.
I'll go into the details.
Yeah. Well, we'll keep on organizing such
Yes, sir. Sure.
webinars. So thank you once again,
Thank you,
Dr.
sir.
Chowdhury. I know that he is one of the outstanding researchers in so many areas, because I personally know what he has done and what he has and what he is leading today. He is one of the main players in IBM. So, okay, so thank
Thank you,
you
sir.
very much. Our
Thank you.
next speaker is, I think, Dr. Saha. Chandranath?
Yes, sir.
Chandranath?
Dr. Saha is with us. So thank you very much, Dr. Chowdhury. It's a really
Dr. Shah has joined.
You can give a formal, yeah. So thank you very much.
yeah, yeah.
Thank you,
So,
Shyama. Thank you very much.
so, yeah, thank you. So Dr. Arindam Saha is with us. He, he got his PhD from XLRI Jamshedpur, and it's wonderful. He has worked in National Stock Exchange and Bombay Stock Exchange as well, and currently he is managing director and co-founder of Vista Intelligence, and he has like many, like around 20 years experience in Indian financial market, and he has also have global knowledge, like for the world financial market as well. So we are very lucky to have him, and we are eagerly waiting for his talk. So Dr. Saha, we
Okay, so
warmly welcome you
Chandranath,
for this workshop.
Yes. Good
Yes,
afternoon,
sir.
everyone.
Chandranath, one of the important
Yes,
points
sir.
should be mentioned that all the speakers are also adjunct professors of JIS Institute of Advanced Studies and Research. So Dr. Chowdhury, Dr. Saha, or those who
Yes.
spoke yesterday, all of them, they are connected with us. And they will keep on taking, lectures. I mean, they are very busy, so naturally, from time to time, for the students and for everybody in the country. Yeah.
Okay, so
Thank
can
you,
I
sir.
share
Thank
my
you, sir.
screen
Thank
or
you.
should I begin or?
Yes, please. Yes, please.
How do I share my screen?
Yeah, there is a up arrow in lower portion. Present now option.
Okay,
And
just a
just
second. Let's see. I'm getting more
then
options
your entire
and
screen.
okay, just a second. I'm getting more options. Inside it, there is nothing.
Your entire screen and just
No. Beside the more options.
Yeah, up arrow I have figured out.
so it's better just click on the your entire screen.
Got it. Yeah. So I guess now my screen should be visible, and I'm turning off my video to save some bandwidth so that we can talk and
Yes, it's
listen.
coming.
I'll be yeah. So first of all, I'm grateful to Professor Ray, Mr. Professor Ajay Kumar Ray, for giving me this opportunity to speak to JIS faculty, students, and other guests who are connected in today afternoon. And in fact, it was a mistake on my part. I somehow was thinking that my presentation is at 4 o'clock, not 3. Good that Abhishek has given me a sweet reminder, and possibly I could connect on time. So it is 3 minutes past 3. So let's begin. So let me put the things the way I should go. My idea is that most of the speakers have so far are mostly are from academics, so they might have dealt with theory and the progress in literature and other things. Here, what I want to do is slight departure from possibly what you have witnessed yesterday and today. I would like to share 3-4 things. One, of course, where Professor Diganta Mukherjee ended yesterday. I was in his presentation. I was listening about NLP, about languages, mostly English and vernacular, how it is dealt with, etc., etc. I start from there and showcase some experiments that we have done in course of our journey, so that the one that you are going to see on the screen is not actually a product, but we thought because we are using sentiment score in one of our regression or machine learning experiments, so why don't we give it a little bit of UI look for users to have benefits of it. So I'll showcase how we are doing that. Second portion, I would like to show you one of the things that we are trying to attempt is basically arbitrage prediction using quant model as
Sir,
well
are
as
you
machine
sharing
learning
the
model.
slides? Because we can't see
No, I
the
will. I
slides.
will. No, I have not started sharing the slide. I will do that. And the third portion I will do is
Okay, sir.
basically, give you some, let's say, call it kind of challenges, 2 things that we are willing to attempt in coming weeks or months. And if you have some ideas, great ideas, then we can jolly well incorporate those ideas. Now, let me start sharing the slide. Uh, let me. So the topic looks like this: the scope of machine learning in financial markets. And though I'm talking about the scope of machine learning, but let me make it put a strong disclaimer that I am no way an expert in machine learning, but because of this startup and because of my working closely with the financial market experts, I kept on hearing this term, and because of the startup, and now possibly my research team is trying to create some wonders out of data using machine learning and trying to make sense of it. So let's get going. It's just a small presentation. So I get that I will not bore you sufficiently. So we are calling it feed sense. So there are lots of feeds available in the financial market. One source of feed is basically your data, hardcode data, numbers. The other source of feed is basically which is of new age thing, basically Facebook noise, hard on the street kind of things, or even these companies who make time to time disclosures to regulators, ministry and all that in forms of, let's say, annual reports, in form of, let's say, corporate actions being notified on regulated exchanges where they are listed, etc. So there are a lot of text which Professor Diganta Mukherjee tried to speak yesterday. And of course, because of the advent of the social media, blogs and so on and so forth, so people have become more opinionated. So people have started talking more than ever before. And if you can aggregate what they are talking and try to, let's say, move the outlier noise, possibly you get a sense of what is going to unfold tomorrow, because people jolly well put forward their expectation of markets. They put a lot of views on the market. So basically, two things as compared to, let's say, 10 years back or 7 years back, it was basically data earlier, time series data. Now, along with time series data, you have a lot of text which are getting analyzed and fueling prediction models. So what my organization or our organization trying to attempt is basically we are creating prediction engines for the simple reason that people have infinite appetite to know what is going to unfold tomorrow, day after, and even beyond. So right from the ages of Nostradamus or prior or even prior till tomorrow, people are always willing to understand or trying to guess or outguess what is going to unfold tomorrow. So it is not only restricted to capital market. So Vista per se is not want to restrict itself into capital market prediction, but going forward, we can also get into agriculture, electricity, power, and whatnot. So we are trying to specialize in prediction engines. So as the talk of the today's session is basically restricted to financial market, what we are trying to do, basically trying to help investors in many ways. One of the ways is basically helping them to, broadly speaking, help them to create wealth, be it in terms of choosing right instruments or be it in terms of deciding the horizon when they can maximize their investment, etc., etc. So basically what market means for an organization like us are basically two sets of people. One is business to business and business to, let's say, retail or consumers. So one set of corporates is basically your structured institutions like bank, FI, DI, foreign hedging funds, asset management companies, etc. Second set is basically carriers of products like, for example, LIC in the insurance front, like, for example, let's say Edelweiss in the stock market front, like, for example, let's say Motilal Oswal asset management company in the PMS front, etc. And of course, there are 130 crores individuals in India and possibly 650 crores across globe who are in the retail segment. So this is the user community which we are trying to attempt. As I said, we don't want to restrict ourselves into equity or stocks or commodity, bond, etc. We can foray into electricity, weather-based agriculture prediction, etc., and whatnot. So part A, I'm quickly moving into the core thing where, and as I said, I'm starting where Professor Diganta Mukherjee has left yesterday. So that means he spoke about making sense of lot of unstructured elements like newspaper clippings, like blogs, like somebody writing in a website, tweeting, Facebook, or any other thing that is possible under the sun. So now, what we are trying to do, this is basically a nifty plot right from, let's say, 2000, if I'm not 2014 to 2020 possibly. And you can see there are two arrows as my cursor is moving, one showing lot of clips. Something must have happened in the market and therefore the market has reacted, which is quite obvious. But hitherto, analysts used to restrict themselves to understand this green up down time series data, trying to see what is going to unfold. Although the fact remains that these newspapers or these news noise or these sources were actually the catalyst behind the market moving ahead in time. So we are trying to first teach the machine, so to say, through some retrospective analysis of market trend, why the market has shifted from a peak to bottom or bottom to peak, or why it remained flat despite some news or despite there's no news, kind of. So we sourced news from two sources. One is Bloomberg, another is your this Wall Street Journal, 10 years data, and we have also data from Ticker Plant India Limited. These data we are trying to plot against each of those time-stamped market nifty movements, and then wanted to figure out why the market moved. So this is one attempt that we are trying to predict impact of news by teaching the machine using time series data as well as news from three sources. This is what we are trying to do. Why I'm telling you, I'll show you the progress that we have made, except this part has not gone live yet, but the other parts in the following slides like this. So we are taking news from two sources. One is Twitter, another is RSS, which are basically free sources from various news organizations like Times Group, Hindustan Times, etc., etc. And we created in the middle portion some algo, and from there we are trying to sort of produce curated news. This is one second attempt that we are trying to do. This is real time, of course. And the third is, while you start these sort of things, that news recommendation system or news summarizer system, there is always a problem, particularly in case of news recommendation system. Suppose I am an user of this Vista's news engine, forget the prediction portion of it for the time being, and then I have the machine or the organization will have two challenges. The organization doesn't know my habits, what kind of news Arindam Saha wants to read. Is it financial news, it is sports news, or is it some politics, political news, etc., etc. Even if it is a financial news, is it related to only corporate news, or it stretches to commodities or bonds, fixed income, blah, blah. So basically machine does not know. So what we have done here to solve this cold start problem, we have 60% weightage we are assigning to all other users' taste and preference, and 40% and what is trending. Now with time, the machine starts and then machine picks up my key habits. The way I'm keying in some, search words, I'm trying to search news on Anil Ambani Reliance Group, or Mr. Mukesh Ambani Reliance Group, or for example, Mr. Kishore Biani Futures Group. Then the machine starts learning, okay, this guy is interested in FMCG, this guy is interested in petrochemical, etc., etc. And with time, then machine starts dropping in news with regard to my aligning the prescription with regard to my taste and preference. So this is we are trying to short. This is actually, it looks very simple, but when we started working, it gave a lot of headaches to us. Now, this is how the recommendation system works for us. As I said, basically, we are trying to combine news from three things. One is retrospective analysis, another is Twitter, another is real-time framework or reinforced learning framework. So this is how it works. It's basically a cycle, and the news is getting fed into the recommendation algorithm, and set of recommended news therefore are plucked out and are fed to the user. And this is how it works. And this is also a system diagram. We are using REST API to publish the output, etc., etc. Now I straight away go to this live site. We will enjoy more You have to mix it with what Professor Diganta Mukherjee told yesterday and what I'm trying to show. This is the...
Sir, can I ask you one question if you don't mind?
Yes,
for
please.
me? Sir, as you said, in real time you are handling. May I know, in real time, what is the ratio between the training sample and testing sample, as you are doing on live basis?
Okay, these are actually the secret sauce. So I will invite you to our organ.
In general, I'm just asking in general.
I will talk it in private rather, because we are applied for certain IP related things. Why don't you drop into our office someday and have a talk one-to-one?
Okay, I'll do it.
Because
Okay,
I'm
sir,
talking in a recorded line, so I have very lot of restrictions now.
Sure, I'll do that. No,
Okay.
Thank you.
So what you are saying is a recommended news site. So we are doing 5-6 things here. So the original idea was to get a sentiment score. As I said, so I am talking in a lot of silos. So you have to basically be attentive to add them up to make sense of it. So as I said, Vista is an organization which is trying to predict things. Now, when you think of a regression equation, let's say it's a multivariate regression equation, you have a lot of covariates. So when you are predicting Nifty, so some common sense covariates could be like historical performance or historical time series data of Nifty. Let's say performance of individual companies which are constituents of Nifty index. Let's say, for example, how Joe Biden is talking. Or let's say, for example, how Afghanistan is behaving. So everything, or let's say, for example, foreign exchange reserve, or the foreigners pumping in money in India. Lot of things are standing as covariates. So one of the covariates we are very curious to use so that we stay ahead of the curve is what people are talking. So people may be talking in the market through, as I said, Facebook, Twitter, and everything. So we are trying to assess what people are talking in a scale of -1 to +1. So -1 is the most negative and +1 is the most positive. So for us, this point is actually of importance. But to do this, we have to make our hands dirty, plowing through lots and lots of news and etc. And therefore, this system was given birth, basically. We are only interested this sentiment score, which is basically point on this sentiment curve, as we were seeing -1 to +1. And we are using as a covariate in the regression equation. I'm not talking in the machine learning part of it because we started as a quant model and then we are progressing to machine learning model. So now what it has given birth to, for example, so all news has been, to make this sentiment score, all news has been classified into negative, positive, or neutral news. Like, for example, you see a yellow, don't get into the UI part of it, this is getting drastically changed. Now, it's just for our own assessments, we created something, and then we are doing little bit of product. When we are doing productization, then we'll take care of the raw UI. So this yellow stamp means this is a neutral news as far as the market is concerned. It may be positive news in some with reference to something else, but as far as Nifty movement is concerned, this is actually a neutral news. Just a second, Shuja, can you just shift to this room? This noise is actually. যদি কিছু মনে না করো ওখানে চলে যাও আচ্ছা so this yellow portion is basically a neutral one. This plus means it's a positive news as far as Nifty is concerned. This is one. So all news has been classified as plus, minus, or neutral, and then news has been bucketed in terms of economy, trade, and there are many more. We are just displaying 3 here for the sake of explaining to people. And why we have done the bucketing, because for example, if you are trying to, let's say, predict the price of Reliance, we'll only be interested in news related to petrochemical. We are not interested to news related to real estate. So we have bucketed the news therefore, and all these are being done using let's say text analytics. Now this is third. One is I said sentiment score. And you can, this is our product features. You can always go back in time calendar and see how sentiment scores are changing, etc., etc. And so one is basically newspaper stories that has been classified and bucketed, and second is these feed sense, Bloomberg or any Twitter stories that has also been bucketed. And we are also picking up keywords around which, if you may recall, Devendra was trying to say there are a lot of words which are basically guiding principle for this sentence, and some words are preposition, some words are noun, like he was saying, you may like me, something, you like me or not. Some examples he was showing, one is like was used as a preposition, and in other case like was used as a verb, right? So likewise, we picked up the keywords which are basically noun from, just a second. See, these stories are getting changed. As soon as I'm refreshing, the stories are getting changed here. So these words are getting picked up, which are the basically keywords inside the story around which the story is woven. So this is another feature. And as I said, a lot of bucketing has been, like it is on automobile sector, like it is on banking sector and company IPO, pharma sector. So this sentiment score or this bucket specific sentiment score will be used in predicting stocks, like let's say your pharma, Dr. Reddy's lab, something like that. Right? Now I get into inside a story, let's say any story. For example, I'm clicking on this, let's say IT sector, let's say pharma sector story, Dr. Reddy's. So what you see here is a smart summary. This is also a summarizer that we have used, and we have plans to give you summary in 2 lines, 3 lines, or in any customizable length as user would deem fit. So this smart summary has been done using some AI algo. These are the basically keywords, laboratories and JIS Pharma and Reddy are around which the story is written, and some historical stories that might have appeared elsewhere, including this source in past dates, and what was the sentiment of those stories, mostly towards positive, and there is no negative stories on this, either neutral or positive. No negative stories have surfaced in last 5 days that have been plotted here. And you scroll down infinitely, seemingly infinitely, you get a lot of stories which are basically around this central theme of the story. So this is what we have achieved using this news recommendation and summarizer system. But as I said, our interest was never to create a news recommendation or summarizer. We are only interested in getting this sentiment score here. So this is, here I stop as far as this portion application goes, which is basically NLP oriented. And we have certain other plans on this, which are in the research desk. So they will possibly come out of it very soon. So now I move to the part B, which is a construct. Now, why I say so, when you talk of markets, people are basically interested into 2 types of trading. I mean, there can be n number of styles which people adopt when they invest or trade or speculate or hedge, whatever you say. I'm not getting into the nuanced definition of those terms because they carry a lot of sense for when you make a fintech products. But I'm just trying to say in short, I broke the whole investment trading or speculation or corporate hedgers community into 2 parts, trading style wise. One is that I predict naked. So I say, look, tomorrow Nifty will go up. Or I say tomorrow Nifty will go down, or I say Nifty will remain unchanged. This is one style. Accordingly, I trade. So if I believe the Nifty is going up, I buy. If I believe that, let's say, a ITC stock will go down, I sell. So basically, I'm taking a naked risk and I'm not covered. Like you do an insurance for your health and other things. Basically, you pay premium to cover from yourself from any future risk, right? So here I'm not covered. I'm just taking an open call. Other style is that I take a hedged position, meaning that what I buy, I believe it will go up. At the same time, I cover myself with something which will go down, and therefore I say, hedge myself. So let me exemplify so that you can understand. Look, these are basically 2 time series plots stock A and stock B. Let's say stock A and stock B are from the same sector, which could be pharma, could be, let's say, car, automobiles. Let's say one stock is Maruti, another is Mahindra and Mahindra. You all know during this last, when this COVID started and this lockdown was enforced last March, people were asked to stay indoors, people stopped buying cars and other things. Last March, it was a negative history created in terms of Maruti. There's no car sold in Maruti. So do you expect in real life that Maruti has not sold any car in the market because of lockdown, but for whatsoever reason, Mahindra and Mahindra was selling cars in thousand? It is not possible. So therefore, stocks which are from the same genre or same industry, they are expected to move in tandem. So one can, for the time being, can perform better, other may remain little bit agnostic to positive performance, it can remain flat, but over a period of time sufficiently, they will move together. Like here, so these curves have started moving mostly upward trend and then it became flat, right? But in between, if you notice carefully, they are coming closer and they are distancing themselves from each other. That is also happening here, right? So there is a mean gap between these two. So one stock price could be 102, other could be 90. So the gap is, let's say, 12. Now this gap can stretch to 15, can come down to 8. So ultimately, if you study over a very long period of time, you may discover the gap is actually 9.5 or 10. So there is a mean gap. So you expect this gap to remain, to cross at some mean number. So basically, point A, you are identifying two stocks which are from the same industry, therefore the prices are expected to move in tandem. B, you expect there is a mean gap between these two stocks. And C, you expect these prices will cross or touch, come down to this mean stock if they have become dispersed, or if they have squeezed less than the mean stock, then they will expand to touch the mean difference once again. So what happens basically when this peak is reached, where my cursor is now, you basically sell this stock because you expect it to come down, and you buy this stock, you expect to move up to the level where the mean gap should be. So this is called pair trading strategy, and this is basically less risky strategy vis-a-vis the other scenario that I buy this stock or I sell this stock doing nothing on the other stock. So this is called arbitrage strategy or pair trading strategy. Right now, what happens is basically so this is a pair, as I said, is related to arbitrage strategy. Now, can I apply quant model and can I improve it further using machine learning things? So in next 3 slides, I would like to show what we are trying to do. Again, obviously I'm not revealing much. In fact, one of your co-students is part of the team who has been assigned this work. She is doing it. I don't know whether she is here or not, but she is part of the job. So I go back a little bit on the theory side. There are 2 ways. One is a classical method. I take the whole universe first, whole universe of stocks, and generate all pairwise combinations, because I have to pick 2 stocks, or I can pick, let's say, 1 versus many or many versus 1. But these many are basically from all automobile stocks versus all pharma stocks, or 1 automobile stock versus rest automobile stocks. Kind of those combinations are possible, but for the sake of simplicity, let us restrict to 1 case. So 1 stock from X industry and another stock from the same X industry. If you are doing that, so basically we have to first pick these 2 pairs, 2 stocks, like I spoke here, Maruti and Mahindra or Tata Motors, let's say. So I have to identify Tata Motors and Maruti first as pairs. So how do I do it? Otherwise, what will happen? Let's say, for example, S&P 500, the US market, they have 500 stocks connected to it. That means if you are picking 500 C2 combination 2, that means you are basically talking of a combination of 1 lakh plus stocks combinations. So can you do it in manually? Can you talk have evolved some ways so that you pick 2 out of these 500 which are ideal pair? I mean, there can be pair, like for example, if you let's say you stop here, and forget this portion exists, which are basically the flatter portion. So what is happening here, they are looking like pairs, but after this they are increasingly becoming separated from each other. So they are not reverting to the mean. So this is, though they are a pair, but they may not be a pair. So it could so happen that government has come out with a policy, which is basically electronic vehicle policy. And this company has adopted this electronic vehicles technology, but this company did not. So ultimately their sales dropped and their sales increased. It could so happen. So basically, the first challenge is that I have to identify pairs which are statistically or machine learning wise significant, and then I have to do various similarities. I'm putting it in naive literature language so that I get communicated to you. So I execute statistical similarities to identify, to reassure myself whether the pair selections are correct or not. So a lot of similarities are there. For example, distance based, co-integration based, correlation based, and hybrid cases. I show you in next. So these are approaches to pair selection. One is of course a very naive approach. It was 1990s when this technique, Gustave paper was there. You can always refer. This paper from 1990 to this machine learning and copula. These are reported to be giving the best results today. Now, when I say your this thing, co-integration, you understand what co-integration is. Co-integration incorporates a lot of tests like eigenvalue test. It also talks about Johansson test, and all these are basically statistical things, whereas machine learning is slightly different. And I will end today by showing you how quant model are different from your machine learning techniques. So this is how we are trying to progress. One is of course state zero, means when you start the work, you have price series which are basically historical price data and high frequency data, because trade happens every seconds or every nanoseconds. So you have huge loads of data which are basically trade data. Now the next challenge is basically from those data, they may have lot of sense attached to it. You have to reduce dimensionality, right? So this dimensionality reduction is very, very important, and it is not an easy task to do. So just a second, I slipped. Where was I? Sorry, this is so we do this dimensional reduction first, and we calculate the return series. We are not interested in the price because it is a market. We calculate the return series, and one of the thing that is getting used in machine learning, they are using principal component analysis for dimensional reduction, because principal eigenvalue, eigenvectors help you to identify the which one is the main culprit in decide, or the main pairs, etc. So we use in the state one basically price series, and we use principal component analysis for dimensional reduction, and then we get certain eigenvectors, eigenvalue to arrive at the things that we want to move to the next level, which is basically unsupervised learning. And here we apply a lot of optics to decide on the cluster. Like this cluster is very dense, so this is the most useful case vis-a-vis the other two clusters which are less populated. This cluster, as you see, is quite dispersed, even though there is a co-integration, there is a correlation, everything, but they are not as dense as this. So we choose the cluster which is the most dense, and finally we apply a little bit of rules and to select the pairs that we want to move ahead with. So this is the first and main component in deciding pair selection. And now we apply a lot of things like RNN network or even neural network, etc., backpropagation. These are the terminology that you guys are expert in that. I don't want to talk. I'm just throwing the market product-wise, what are the challenges lies ahead before you apply or think of machine learning, and so that it can be adopted for successful takeoff of a product. So we do co-integration test. If co-integration exists or not, it doesn't exist through Angel Granger test or Johansson test, etc. And then we make sure that its spread is mean reverting. Like I've given you examples of lot of graphs. Sometimes they are crossing each other. That means the mean is becoming 0. There is no difference. This is the ideal scenario. And in fact, when you create a product through machine learning, you should be interested in cases like this top, let's say this topmost one rather than the bottom ones, because bottom ones, they are not crossing each other. Yeah, in the top case, they are crisscrossing each other more number of time in the same time periods as compared to the other 4 cases. So as a product organization, our interest should be to pick pairs which are crossing each other or coming closer to each other the maximum number of time, rather than the one which is on the bottom, which are staying away from each other or not coming closer to each other most number of time, right? And how the machine learns using, as you said, know very well that RNA, neural network, back propagation, your this thing, gradient descent and other things. Those are basically theoretical portion, and I'm not an expert, so you guys know how to use it the best. Now, I show you a little bit of results. These are actual results. Though on the left, what you see, which I plucked out from a book on machine learning pair trading. So this is an actual experiment carried out on S&P 500. So they initially witnessed 46 clusters initially, and total number of pairs was 631. From that, and possible number of pairs was, as I said, 1,27,000 something. From that, the final set of pairs came down to only 23, right? And in our case, which is the Nifty 50, which we have worked out, this is the results from the quant model, and we have used some very little elements of machine learning. And this is giving a success ratio of 66%. That means out of 100 calls that the system is generating, 66 calls are right. That means we are able to predict pairs correct, and therefore the trades are also becoming correct. And the return is 96% or 97%. This is post cost. If somebody has invested 100 rupees, he can get 100 rupee back, 100 plus 100, principal plus profit, in 1 year time, 200. So 96% return. And in a year, total trade generated were 15 and profit window was 6. And the pair that we have chosen is TCS and Infosys from the your area, basically information technology basket. So, okay. So this is so 6 plus 2 window means, sorry, this is 8 months result. So 1 month is one window that we have chosen, and this is on futures, on derivatives. So those are nuances. So I'm not avoiding it. I'm sure most of you are not aware of those things. So I'm just showing the results here. One result is to show you how number of pairs have trimmed down to only 23 from 500 C2 possible cases, and the other is basically from Nifty 50. So 50 C2, possibly 1200 number of pairs possible. We chose TCS, Infosys, and few other pairs. Out of that, I am showcasing only one result to you. I think I have been given an hour's time. It is 3:40 now. The last portion I want to get into. I spoke first. I extended the talk presented by Professor Digant Mukherjee yesterday, and I showcased how the product has been created using the knowledge that he has, theoretical background that he has shown to you, and how we are willing to or about to use the sentiment score. That was part A. Part B, I said there are two strategies for two sets of people. One is a risk lover, another is risk averse. And risk averse strategy is basically arbitrage strategy. And I showed you one arbitrage strategy, which is pair trading, which is very popular across the world, how it can be used using machine learning and other things. So the third portion, it's like you participate in hackathon. I am also interested to create products. For me, that is hackathon. So I am showing two product ideas. If it fascinates you, you can start working right earnest, or you can collaborate with us. One is, for example, so one of the challenge before, one of the challenge before this Investor is there are investors, there are traders, there are scalpers who are trading every minute. They are called scalpers. They are scalping profit, 1 rupee, 2 rupee. They are scratching it on the screen every now and then. They are trading. So Calcutta, if you don't know, is the hub of those scalping trading. Now it is not done manually anymore, or mostly it is done electronically. A lot of IIT grads, lot of brilliant minds, postgraduate PhDs are working in the markets day in and day out. They create algorithms, sophisticated algorithms, and huge processing power machines they use, and they generate trades. So basically here, but there are other people also. They are not habitual traders. Like for example, professors who are in the call, sir, and some of us who don't trade every day. We often trade once in a year, once in a half year, once in quarter, etc. So we want to pick stocks like Infosys in 90s. People who have bought Infosys in 90s are in crores now, because the stock return has given them multiple percentage of returns, and many times over, so to say. So I am interested to identify stocks which are basically hidden gems, which are young companies but has huge upside, can rise many folds. How do I identify those stocks? Those stocks, the challenges is those stocks do not have a legacy trading. So the time series data, which are often exploited, like I showed you, are not just available, or even if it is available, it is thinly traded. So people don't rely on those time series data that great. So is there a way? There are two ways. One, two, three things you can combine. One, for example, you can analyze the economic scenario of the country that you belong to, or the globe at large, or the world at large. So for example, people today are talking of, let's say, solar panels. So electricity sector is going through sea change now because of global warming and other things. People are also increasingly talking about, let's say, machine learning. So hardwares are becoming much faster, sophisticated, etc. So is there a company who is building chips, hardware chips and other things? Can I pick that company? So identify the sector where the government focus is, or where the world is moving into. So economic scenario I want to understand. So now, for example, you may think, oh, that's very easy. I understand that, for example, people are moving away from, let's say, coal-based technology to solar, or let's say what they call is basically green electricity, etc. People are also, I know for sure, people are moving into, let's say, hand phone. So mobile industry is another. I know for sure people are talking of high speed, so fiber optic cable. Any company in that are basically dudes. So is that everything, or how do you analyze that? So economic scenario, let me give you this thing. So for example, there are 4 or 5 companies in India who produce this economic data. Now these economic data are basically, you can think of, let's say, GDP number, GNP number, etc., etc. But actually, when you talk of economic data, it can run into, let's say, lakhs. So I have a data set which I'm accessing, which has 7 lakhs titles. So you have to put those 7 lakh titles in the system, and machine will process. So how it is done in, let's say, in today's analytics, big data analytics. So earlier people used to form regression equation, multivariate regression equation, etc. And regression covariates used to take various forms, like for example polynomial, and you could deploy a matrix if it becomes heavy and other things. But today you put, and you know for sure that because you do little bit of empirical study before you start the regression, to identify whether there is a multicollinearity, to identify whether that particular covariate that you think actually influencing the dependent variable y, whether they are actually having some relation, or it is just a spurious relations. So you figure out those things using statistical tools. But those things are possible using only finite number of variables. When the variables become as large as 6 lakhs, 7 lakhs, then you can't just do it. Then you have to basically put it in the machine. Machine through neural networks will understand what thing to consider and what to drop. This is my last part. As I said, I will tell you that how it is different from quant analysis. This is the first departure. Here, thanks to this development of machine learning, other things, we don't have to bother about whether a particular covariate is linked to a particular dependent variable, or it is just a spurious relations beyond what I'm believing so far to be true. So n number of seemingly infinite number of variables like this, in this case economic scenario related variables, can be processed simultaneously, and the machine will decide how much. Not only machine can do two things. One, machine can choose the right variables A and drop the variables which doesn't matter. Second, machine can assign coefficient weights. So whether a coefficient will be given 90%, 0.9, or it will be given 0.4 decimal, then 9. So everything machine can be left to the machine to decide, and machine can, over a period of time, machine can learn also. This is what we are trying to do in the economic scenarios. I just quickly in 30 seconds will try to show you how just to show you how it is important. This is another presentation for some other day for someone. So look, the market over a period of 1 year has risen 57%. Over a period of 5 years, it has risen 90%. In this jungle, can you pick up a stock which is basically a multi-bagger or a future Infosys? So to do that, I was telling that guy, look, you need to analyze all these things. So basically economic recovery. These are all parameters which are making sense. So gross value formation, then FI participation and DI participation, international trade, how much international trade has happened, then consumer price index and vis-a-vis Nifty, then for gross formation of capital in India, and disposability, how much money people have and all that, everything. So all these economic parameters are, and how mutual fund money has come in. So currently 30 lakh crores of mutual fund investment has happened, which used to be hardly 10 lakh crore about 7 years or 5 years back. So all these things, indices, commercial vehicle parties, so whole lots, including weather. So how monsoon affects markets, everything. So all these are basically your economic parameters, so to say. Now all this needs to be, this is only possible to be attempted using your big data analytics or market machine learning techniques. Second is financial statements. So for example, every company, this is again a numerical data. So first two blocks are numerical data. So life is therefore little easy. So the second, as I said, the financial statement, which is with regard to, let's say, annual balance sheet, quarterly balance sheet, cash flow statement, profit loss statements, everything. Like JIS, though it's an I believe it is a society or something, still it has a cash flow statement or other things, because everything needs to be accounted for. So those financial statement does reveal whether the company is managed well, whether the company is not managed well, whether the company is actually for siphoning of funds. So those financial statements are very critical. And the last is, as you have seen in my first attempt to share something that I believe is important, is basically corporate buzz. What corporates are talking. So corporates make lots of announcement every day. Like for example, Reliance few years or months back possibly wanted to, somebody is trying to, okay. Tried to talk about, let's say, merger with Futures Group. Then Futures Group tried to create an some agreement or association with Amazon, and all those things happen. These are all corporate buzz. So before they announce to the SEBI or the listed exchange where they're listed, let's say now National Stock Exchange or Bombay Stock Exchange, there must be some talks in the social media. Can I capture that? So this is of interest, and once you combine all these three things, you come out with something which is basically financial statement analytics in whole. So the challenge is, from the listed 5,000 company, number one, you have to pick one company or few companies which are basically future TCS or future Maruti, etc., etc. And from financial data, which may be 1,000 headers or 1 lakh headers, you have to find 1,000, meaning after all this back propagation or dropping, you come out with 1,000 things which have a significant coefficient value. Anyway, it's an inapproximate equation form. So the form changes every now and then between dependent and all these covariates, etc. And this economic variables, which may be 5,000 variables, and then text, which I wrote infinite. Can you make sense and create a product? So we have worked out certain formalities. We are trying to do this. Possibly, if we do this, I believe that even if it is not something innovation, but it's more than a discovery. So this is one thing that we are trying. The last slide, and I will end on time, is basically, as I told you, so this is actually a structure of a famous product which is created by a large financial institute for their investors. So they from time to time come out with certain selection of financial instrument where people can invest. So the basis of those selection, it may be a 10-page long document. In 2 lines, if I have to describe, one is, as I said, they identify highly traded stocks. So they don't pick stocks which are not traded heavily or not of people's interest. So they trade, let's say, they pick stocks like State Bank of India, not like, let's say, for example, ADC Bank Limited. I'm not naming any banks. There are many small cooperative bank or state bank, state level banks, etc., or Grameen banks, etc. So I'm not naming that. Let's say State Bank of India most traded. So in the banking basket, I settle on this. And then I pick up stocks, many stocks like this, and I assign weights to these stocks. And I tell the investor, look, in SBI, you invest 20 rupees. And in other stocks, Infosys, you invest 30 rupees, etc., etc. And my selection is based on these things. Now, I am repeating myself. Here, what I am doing, the selection of stocks is based on certain thumb rules, which I believe I understood best. Second, I have not only chosen the stocks to best of my understanding, I have also given it a color and saying and dictating that, look, in this stock A, you only invest rupees X and not Y, and X can be less than Y, etc., etc. And I have chosen the stock based on, again, some fancy that I believe I am an expert. Trailing return on equity 20%, 3-month fiscal EPS estimate revision 30%. So whoever has fallen into this criteria, I have done that. But in real life, now the world is moving towards this. This stock selection is, you just put a lot of garbage, and it is not garbage in and garbage out that machine or the neural network produce. So it omits things which it thinks is senseless, and it assigns weights to things which believes has some sense. So these weights are assigned by the machine itself, and people doesn't do anything. But yes, what people does painstakingly is people does this type of things, and this is the, I believe, the more toughest part of any machine learning or reinforced learning exercise, that you have to teach the machine. Like you teach a young kid again and again, still he makes mistakes, and then finally with age and with time, therefore, and with a lot of reinforcement that you put into the child, it becomes perfect. So likewise, it also gains experience through machine logic, gains experience through your training. So these systems, one of my learning are humongously data hungry, and these systems are requires a lot of investment. It is not easy, but if you do it, provided of course you have the domain knowledge, you just can't put, let's say, China's data as the only source and expect that data to pronounce how Indian stocks will perform. China's stock market data or economic data are useful as an additional covariates, but if you don't understand domain, you will miss Indian data, which is basically the main ingredient for cooking a biryani. You need basmati rice for cooking a biryani, and then other things can be added as per the requirement and taste and preference of the people who are serving or people who are eating, right? So I end here. I think I'm dot on time, 5 minutes to go. And let me open this and stop sharing. So this is what I wanted to share, and I'd be very curious to work with institutes like JIS, and I'm believing that what we are showing today in the area of capital markets. Tomorrow it can become a game-changing products for the markets. Okay.
Thank you, Dr. Saha. It's a wonderful talk. So I ask the participant if you have any question, just ask directly to Dr. Saha. Or here, Saugata Bhattacharya, he has raised his hand. So would you like to ask questions, Saugata? Or any other students or researchers want to ask question? Okay. Still, some of you have any question, just directly email us. We will forward that email to Dr. Shah.
Yeah,
So
always.
once again, Dr. Shah, thank you very much. It's
Yeah.
really wonderful.
Thank you. Thank you very much.
So our next speaker is with us, Dr. Suman Sengupta. Mr. Suman Sengupta, you are with us now. Hello.
Yes, I'm there in the call.
Okay. Thank you, sir. So, Mr. Suman Sengupta, he is a CTO of HiQ Solutions Limited, and he is also adjunct professor of our Center for Data Science, JISIASR, Kolkata. He has vast experience on industrial training, and he was official trainer of IBM and other MNCs, and his working areas are embedded system design, machine learning, AI, IoT, cloud computing, data warehouse, and data visualization, big data analytics related area. And he completed his BTech and MTech both from IIT Kharagpur. So we are very lucky to have Mr. Sengupta. So Mr. Sengupta, you can share your screen.
Yes. Before I share my screen, am I audible to everyone? Could you please get back to
Yes,
me?
yes, sir, yes.
Yes. Uh, I would like to apologize for one thing. Number one, uh, the topic that I am taking is not a topic on trends or uh, current work. I have purposely decided to take on a very basic question of computer programming, which will help anyone learning any language. It is a very basic topic. I guess the teachers and the professors present here are past masters of this, and also a large number of the students understand a part of it, if not most of it. But I would still like to deliver the session because the topic is very, 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 very important if you want to do any serious programming in any language. The topic is that of runtime stack or call stack in any language. So I will be starting with us. I have not prepared separate slides. I will be giving you a link and I will be sharing that link on my desktop, and we will be following the link, but we will do a small set of exercises on Eclipse on Java and then on C in another IDE. So we will tackle these two things. We don't have too much time. So we will try to understand the basics of the call stack or the basics of the runtime stack. Okay, just give me 2 minutes. I will be sharing my screen. please bear with me. Eclipse is opening on my machine, so it is taking a bit of time.
Is there any network problem?
Actually, Eclipse is starting up on my machine. It's taking a bit of time. So I'll be sharing my screen right after that.
Okay.
There we go. I'm sharing my screen. Eclipse is ready. So please wait for the screen to share. Is my screen visible to everyone?
Yes, yes.
Right.
Yes, yes.
Right. So we will be not be doing any we will just discuss something which is basic to any procedural language as well as to most student language. First of all, what is a runtime stack? So I remember when you start your program, an execution environment is created in memory. So at runtime, the local variables of and the global variables are stored in memory. Okay. So when you run main, all your uh, global variables are stored in one portion, and your local variables local to main are stored in another portion. Right. Now, in C, when you call a function, this original environment which we spoke of right now, this goes below, and on top of it, another environment is created which houses the variables local to the function. And after the function call is completed, the second environment gets deleted and we return back to the main function. So enough of discussion without demonstration. Let's take an example. So just look at this. We have a small program in Java. So we are starting with Java. Okay. So here we have let's comment out most of this. We have a class test. The class test has a single property, a string called P1. It has the public static void main function for the entry point, and it also has a static void function F1. So let's just write a small F1. Here we have let's say F1 accept parameter. So this example is well known to all of you, because this is the standard call by value example. So we will just try to visualize what is happening in the stack frame when this is done. So in F1, we are just assigning the value of the variable to be 456. This variable A is a parameter passed to the function. Okay. And we are assigning the value of A to be 456 inside the function. Let's go up. Let's remove all this. Let's just put int x equal to 34. Let's remove this. and let's go down and let's call F1 and let's write here X. So we pass in X and let's do we are just printing the value of X after calling the function. This is it. So we have called F1X. The value of X before calling the function was 34. And we are printing the value of X after calling the function F1X. I will put there next and make it plus. Let's run this. I guess some other project is running. My mistake. Can you see that we changed the value of the variable A in the function, but you still got back the value of X as 34. It was not changed. Why is this? All of you will tell me that in Java, basic data types are passed by value, like in C. Okay, so I will just add here that try to visualize what happens inside your computer's RAM. So basically, the stack of main is there in the bottom of the stack. The stack frame of main is there at the bottom of the stack. On top of that, the stack frame of F1 was built. The variable X, which was passed as A to F1, had a separate storage area in the stack frame of F1, and the value of X was copied to the value of the variable A in the stack frame. So how do we visualize that? Let's check it like this. Instead of doing a run, let's do a debug. So let's add up here and check debug as a Java application. Okay, so the debug perspective will open up. Can you see the stack frame on the left? So these are two threads running the two functions. Test.main is a stack frame and test.f1 is another stack frame. So where has the program stopped? The program is waiting here. So can we look at the watch? The watch is here, 1 second. Let's come here and see the variables. You can see that the variable A inside F1 shows you 34. That is because this line has not yet been executed. That means the value was passed as 34 from inside main. Okay, let's do a single step. Step over. The value of A becomes 456. Okay, now let's run it again. Let's continue. Let's to resume. The value of X is 34. So here it has exited from the stack frame and it has come back to the main stack frame, and the value of X is still 34 because the value of X was copied from X to the new variable A, which is local to the stack frame F of F1. Okay. Now we will see a slightly different thing. We have the class in which these methods are written is known as test. So let's do this. Let's create in main a new instance of test. Okay, test Z equal to new test. Okay, let's set that instances P1 string property to capital A. Okay, and Z dot we call Z dot F1. We could, instead of Z, we call one second. An object. So purposely we have passed the object created in main, where we have passed in capital A as the value of the string property P1. Inside the function, we have taken the parameter, which is an object now, and changed its property P1 to double quotes 456 double quotes closed, quote unquote. Here we print, instead of this, we remove this and we just do println z.p1. So now something slightly different from the last case happens. So let's run it. Can you see that the value of the string property of Z has actually changed in the calling environment itself? This is because, as a large number of you will say, Java passes objects as references. Since it's a reference, and a reference in Java is a slightly complicated handle, which is something like a pointer to a pointer. So basically, when you change any property of an object passed as a parameter, the original object in the calling program gets changed. Okay? So this is the explanation. So let's go back to the concept of stack frames. So what happens here? It is something like passing a pointer in C. So basically, when a reference is passed, when you call test.f1 within brackets Z, let's see what you get when you debug. So let's just put up here and a breakpoint here. That's what we've done. Now let's go here and do a debug as. And we do a debug as Java application. And there we have it. So it's waiting. Where is it waiting? It's waiting at the line test.f1, at the point where you're calling the function. So let's inspect the variables. So in the Java main function, you have a command line argument array, args, string args. You have x, which is 34, and you have z, which, as you can see from here, is an object. So z is an object, and inside z you have p1, and p1 is of type string, and as you can see, this is double quotes a. Okay. Now let's step into and check. Let's go to the run menu. Let's do a step into. And we are again stuck. We are stuck here. Now let's go to the variables window. Here we have A. A is an object which is passed. Now we are in the stack frame of F1. Please note that. The other variables are not visible. Is passed, P1 value is A. Check this. But we check, we just step over. And that changes, step over again. Where are we? We are here. Can we see what is this z.p1? We can see the z.p1 here. That is already changed to this z is in main. Now we are back in the main stack frame, and it has changed to 456. What does this mean? This means that the reference to the object is passed to the function f1. When you write test.f1 within bracket z, z is not actually the object. Z is not a copy of the object. Z is a copy of the reference to the object. So a copy of the reference to the object is passed to f1. And so when f1 accesses the object, it accesses the object from its original position. That is, which is accessible by main also. So when we come out back into main, we find that the value of P1 inside Z has changed indeed due to the change inside the function F1. Okay, so I'm just terminating this. Up to here, it's pretty obvious to all of you, particularly those who understand call by value and call by reference. I'm just giving you 5 minutes to think out a point. What will happen if we do this? Can anyone tell me? What will happen when I do this? What will happen after I run this and I call system.out.println z.p1? Anyone should be able to answer. Please tell me once you have thought it out. I'm just sharing my screen. In case you would like to have a try, tell me what will happen, what will be printed. Anyone? So basically, a funny, very, very funny thing will happen. Common sense says that if you make the reference as null, then this reference Z should also become null. But this is not correct, because please remember very carefully what I told you when I said, how does Java pass an object? It actually passes an object by copy of reference. So first let's run it and see what happens. Can you see? It still prints the A. So I'm giving 2 minutes time to anyone to explain why this has happened. Anyone? So it appears that it's not clear to you. Anyone want to take a try? So I'll just tell you. Basically, remember that it's just like a pointer being passed in C. So when a pointer is passed, actually the pointer is itself a variable occupying memory. So in C, the pointer is passed by value. That means a copy of the pointer is sent inside a function when that function is called. Since the pointer points to a variable outside in the main stack frame. So when you dereference the pointer inside the called function, the original variable is changed. But if you change the pointer itself, that has no effect on the external pointer because you have just passed a copy of the pointer. It is exactly the same thing in Java. Okay, so what happens? You have a pointer A and a pointer Z. I'm saying pointer in place of reference just to show you what is happening. So reference Z is a location in the main stack frame. Reference A is created when you create the new stack frame for F1 above the stack frame for main. Okay, and when you call F1, the value of the reference inside the Z location is copied to the location A inside stack frame of F1. So when you make A equal to null, that location A becomes null, but Z does not become null. Okay, so there is another result. When you return from here, from F1, basically inside main, Z still holds the connection to the original object and prints the value of z.p1, which original p1 was like this. As you see, the p1 was set to A and it prints that p1. Let's come down and try something else. Let's remove this A equal to null. Let's create a new object. Okay. Okay. And we do A.P1 equal to B. And we print out the value of A.P1 inside F1. Okay. And we obviously have the A printout of A.P1 inside main, Z.P1 inside main. Let's run this and check it out. So inside F1, it prints B. Inside A, inside main, it again prints A. Why is this? The same reason. Whenever you assign to a reference passed as parameter, the original reference which was copied when passing the parameter does not get altered. So it points to the old object. If you dereferenced the reference and disabused the object, then the affected the original. But change itself, so it is not affecting the original reference, and thus the original object is unchanged. Do this, we will move over soon to another topic in Java and in C. By the way, does anyone have any questions on this discussion till so far? Any questions? Yes, tell me. Tell me, Shomadip. Please unmute yourself and tell me. Oh, acha, I think. Or you can write your question on chat. Oh, it's clear. You mean it's clear. Okay, okay. Let's just give a break of, sir, is this basically call by value and call by reference? Well, there are different ways of calling this. I prefer to say that basically in Java, basic data types are all by called by value, whereas objects are passed, parameters are passed by copy of reference, not by reference. There is no actual passing of parameters by reference. They are passed by copy of reference. Just as in C, there are warring factions or camps. But I think the grammatically precise way to say is that in C, actually, it's called by value. Even pointers are passed by value. So that when you set a pointer to null inside a function, basically the original pointer remains unchanged. So it's again a copy of a pointer. You don't copy the variable, you copy the reference. You copy the them in just 2 minutes. I have asthma, so just give me 1 minute to recover, and then we can pass over to the next example. Yes, so I am of the opinion that C does not have call by reference. In C, there is only call by value. You can only pass a pointer by value. So we will come to that question if we have the time to do it. You are basically passing either a copy of a variable or a copy of a pointer. So you are passing a copy only. We will discuss that. This is basically the point which we want to clarify today. Yes, Python is a different beast. It's a different animal. We will discuss about Python. Just give me 2 minutes. Okay, let's start again. We are going to do something now. We're going to create a new class. Purposely making all of them public so that there is no need for getters and setters. Okay, this is a very bad practice, but I'm doing it to shorten the programming just to show you a concept. So just look at this. I'm going back to test.java. Okay, and I'm writing here class test. Test 1 T1 equal to new test 1. I'm creating a new property called T1, which is of type test1 inside test. Okay. Now let's go down. Okay, and here we do okay. So I'm asking you the question, what will happen when I run this code? Inside main, will it print the original value of t1.x or will it give you something else? What will happen? Whoever can take a chance, please answer. What will happen there? Anyone? Yes. Imran, I will answer your question. What will it do here in Java? Anyone? So the answer is here, since we have not converted the original reference, that is A, to null, we have changed T1 to null, which T1 is inside the original object A, that is the Z object. So the T1 object of Z actually becomes null. And so you get a null pointer exception when you try to access a.t1.x. Okay, so let's run it and see. Run as Java application, null pointer exception. Why did you get it? Because when z.t1 was accessed, you got null. So let's remove the .x, then you won't get the exception, you'll get null. So let's run it again. Can you see? It actually changes z.t1. Why? Because remember, the reference z was passed as a, and that reference was not assigned to inside f1. So what happened was that the original z object was actually changed. Inside z, you had another object, that is t1. And that t1 was set to null, but inside z. So when in the original stack frame, you try to print the value of T1, it prints null. Okay, just to check, let's put it like this. A.T1 x equal to no, it's an integer. Sorry, my mistake. Done. And let's print z.t1.x. This prints the actual thing. And we run it. And you see that actually it has changed in the object inside the object. So the bottom line is, if you change the original reference, if you reassign to the original reference inside any new stack frame in Java and C, in C pointer and in Java reference, the original base stack frame reference or pointer is not altered in any way. So whatever you do inside the function gets lost. Okay, please think over this. The second point is, if you change any reference which is contained inside the original reference to null. So if you write a.t1 equal to new t1 and you create a new class, new object of class t1, you will be able to reference that back in the main function, because the original reference was a and not a.t1. So you can assign to any object inside the object which is referenced in the original reference. And those changes will be maintained in the calling stack frame. Okay. Any questions, anyone? Please tell me. Any comments? Okay. Okay, then I am putting up to vote. Would you like Python now or would you like JavaScript now? Python, that's one. Anyone else? Right. Another Python. Same example. Okay. So all of you are interested in Python. Okay. Give me 2 minutes time. I need to prepare the Python ID. Just give me 2 minutes. Sorry, the ID is taking too long. The ID was taking too long to load, so I'm using an online ID. Okay, so here it is. I have to share my screen. 1 second. Here we have it. Here it is. So that's an online ID, one of the most popular. So let's do a first example. Let's do so you just incremented a value. Okay, I'm doing increment Z. I guess my screen should be made larger. And I do print and I do Z. Okay, that's it. Let's run it. Let's go up and see what it printed. It still printed 23. So that's obvious. It did not print the incremented value. So basic int was passed by reference, by value. Okay. Now let's change increment. Okay. And let's put Z equal to a list. Okay. And try to see what happens. Let's run it. What happened? Can anyone tell me? Look at the output. It's 2312. So X was a list, Z was a list. I did X dot append 12 inside the function. It appended to the original list. That means that as long as you are not assigning to the function argument, the parameter, Python will accept a list by reference. One look at this. Let's do none. That means null. Okay. Let's run it. Can you see? Z still remains 23. Have you seen it? So the example we took for Java is working exactly the same for lists in Python. Okay. Any questions, anyone? Any questions? Check it out. Check it out on the online ID. Get back to me. I'm waiting for you. Right, Shomadeep. Anyone else? Okay, I'll show you another example from Python. Let's just change this. I've just done x equal to 12, 23. Okay, inside the function, I passed in a list, and inside the function, I assigned to the argument, the parameter passed, a new list. Okay, let's run it. Can you see? The original list is unchanged. Why? Because we have changed the reference. When you write x equal to square bracket 12, 23, Python creates a new list object and shows the next. When you print, after that, if you print the original list, which is unchanged, only change is one x dot append or functions like that. Okay, so any function which does not change the original reference will change the outside object, the list. But any function which changes the outside reference will not be reflected back in the original main execution environment. Is this clear to all of you? We have taken the first step towards understanding passing of parameters, but actually we need an IDE where you can see all the stack frames. So that is very, 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 very important. One way to do it is to run a debugger where you can print each stack frame. So maybe sometime later, we will be able to take a session later on, not today, where we can show you all the stack frames printed. There is a special way to do that. Okay, so that's it. Now Would you like some example in JS, JavaScript? Are you interested in that? Anyone? So it seems that JavaScript has no takers. So let's leave it at that. Yes, I have time. I still have almost 20 minutes time. Not 20 minutes, 17 minutes time. Okay. So I will show you an example from JS. We will not be using the browser JS. We will be using the same online GDB. So here we come. Here we select JS Rhino interpreter, JavaScript Rhino. There we have it. And let's do a control A and delete. Please remember here we don't have console.log, we have print because this is a command line interpreter. So let's do it this way. Let's create a JavaScript object. Okay. Right. So here we have double quotes a colon 1 brace close. So that's an object. Okay. In JavaScript, we create F1 and we pass a variable C and we write C dot A equal to double quotes 2, 3, 4. That's it. Done. Here we write F1 and we write X. Then we write print X. That's it. Right? Let's run it. One second, my syntax is wrong. I have not worked in JavaScript for a long time. It should be just one moment. I have a mistake in my syntax. I'm sorry, I was on mute. I just showed you two examples. I had forgotten that I was on mute. So here we have it. X equal to 12, function f1c, and it prints 12. It does not print 2, 3, 4. But when we put x equal to an object, it actually changes the original object. And here we print c dot a, and we print x dot a, and we get 2, 3, 4 there. There we have it.
Sir, please share your screen.
Oh, my mistake. There you have it. That same example, I had missed out the function keyword. Okay, so it's x is an object. I pass in the x object to f1, function f1. I change the property a of the object, and I print the property of the original object, and I get 234. What happens when we make it an integer? When we pass in an integer as a variable, 12, okay, and here we do equal to x. Here there is no dot a. Okay, let's run it. It doesn't print 234, it prints 12. So when it's a base type variable, that's int, it is by value. When it's an object, it's again by reference. Okay, let's try to see what happens when we do the null. Okay, and we do here. Let's do it. Let's print x dot a. Still it prints 1. The same repeat of the same conception here. When you change the reference, instead of dereferencing and changing the contents pointed by the reference, the original reference remains unchanged and prints 1 when you print x dot a. Have you understood this? This is in the same line as what we saw in Java, in Python lists, and in JavaScript. Any questions, anyone? Questions or comments or whatnot? Right. So Raj Bibor is clear. It's clear to Raj Bibor. Anyone else? So if we have any scope of having a second session, I will enter into further details of the runtime stack, which are very, 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 very interesting. So no questions, anyone? Then let's end the session right here. Any other questions?
Thank you, Dr. Sengupta, very much.
Thank you. Thank you, everyone.
So we hope we will have you once again in near future, and we will continuing conduct more sessions like this. And we also thank all the participants as well for registering and listening to the talks from our wonderful speakers. And you can visit our website. It is jisiasr.org, and we have three centers. One is ours, that is Center for Data Science. Another one is Center for Health Science and Technology, and another one is Center for Interdisciplinary Science. And all the recordings will be uploaded on the YouTube, and it will be also available in our Facebook channel. So you can have a look there as well. Thank you. Thank you very much to all of you, and Mr. Sengupta, once again, thank you very much for a wonderful session. So I am ending this session. Thank you.